Today we're going to be having a look at what happens when we apply a function to a probability distribution. So the following probability distribution represents the mass of cats in kilograms. So these are kilograms at the top, kilograms. Brought into a veterinarian clinic where the cats are vaccinated. They receive 2 milliliters less than 3 milliliters per kilogram. So if they're 2 kilograms, then they would get 6. 2 times 3 is 6. And then minus 2, so you get 4 grams of 4 milliliters, of vaccination. Alrighty, so let's first just work out the expected mass of a cat. So that's E of x, and we're using the sum xi pi formula. So we get 2 times 0.25, 3 times 0.15, 4 times 0.4. and 5 times 0.2. Alrighty, so that's 0.5 plus 0.45 plus 1.2, 1.6, and plus 1. Alrighty, so we've got 2.6, 3.05, 3.55. So the average mass of a cat, or the expected mass of a cat, is 3.55 kilograms. Alrighty, so calculate the expected volume of vaccination given to a cat. Alrighty, well, let's have a think about it. So if this is their average weight, then the average volume will be 3 times this minus 2. So it's just going to be 3 times the expected value minus 2. As per the rule in this sentence here. 2 milliliters less than 3 milliliters per kilogram. So we get 3 times 3.55 minus 2, and that gives us 8.65 milliliters, right? Because we multiplied here, that's converted into milliliters. Alrighty, so from here, they want to determine the expected value for 3x minus 2. So let's actually work out how we would do this. How would we actually work out the expected value for that? So let's have a look. Alrighty, so first of all, let's just set up a quick table, and let's now just work out what 3x minus 2 is. So for the first one, it'd be 3 times 2 minus 2, 6 minus 2, which is 4. Next one will be 3 times 3, minus 2 is 9 minus 2, which is 7. Then you get 3 times 4 minus 2, 12. Alright, this is just a sequence. Alrighty, so now that I've worked out my different values, what are the probabilities for these? Well, now we're looking at the probability of 3x minus 2, which is useful. But where are we going to get those probabilities from? They actually don't change, because we're assuming that the function has been applied evenly across this, and so our probabilities are not going to be changing. Because remember, the function is only changing what we're looking for. Up here, we're looking for kilograms. Down here, we're now looking at how many milliliters we get. So the probabilities of each of these is still going to stay the same. So what's the expected value for 3x minus 2? Well, it's the sum of xi times pi. The xi's have all changed, but the pi's have all stayed the same. And you can see I'm just reading them from the bottom 2 rows of the table. And if you add up all of these values, we are going to get the exact same answer as before, which is what D found, what D is asking us to do. So the 2 answers we got when we did the function first and then did the expected value versus when we did the expected value and then did the function, right? Because that's what we've just done, is that we still get the same answer either way. So for part D, order did not affect the outcome. And that's only due to the fact that we applied an even function across the x values. Alrighty, so hope we've learned a little bit more about expected value. I'll see you on the next one.